want to welcome everybody. And for those that are new to SEA or are joining us for the first time here, our traditional start time is at 5 minutes past the hour. It's not that we're running 3 minutes late, that we will start in just a couple of minutes. And again, for those of you that are new, welcome. And welcome, Andrea.
Hi.
It has been a while. It's good to see you.
Thank you. It's good to see you too. How are you?
Good morning, everybody, or for those of our friends in Europe, good afternoon, everybody. My name is Mike Conroy. I would like to welcome you to SEE 2023. SEE is a simulation exploration experience. It's been a journey for us, a long one and a pleasant one for over 10 years. We've been working with CISO, working with other groups, sharing what NASA did, having the students and the folks that are involved here inform NASA and help us to go build things and go forward with that. SEE 2023 is the end event of this cycle, the actual event that we're in right now. We're going to demonstrate some things. We're going to show the work that the students have done building up a lunar base and a lunar colony. And I want to go walk through with you a little bit as well, kind of how we got here, kind of the things that we're looking at, and really how this type of simulation, types of things that we're doing and the types of things that everybody is building here is a key part of design of systems like these, very, very large, very, very complex systems that are not your traditional design activities. These are multi-decadal, if not multi-generational design projects. And the only way I know to approach this type of work is what we're doing here. And for those of you that are the students involved, you are using and helping define the ways that these types of systems are being developed and designed. And I thank you very, very much for that. Again, this is welcome to SEE 2023. We're going to the moon. We're going to Mars. The folks who put this together, the folks that hold this together, I'd like to go thank them. Simon Taylor is our executive chair. He's at Brunel University. Bjorn Mueller is our industry chair. He's now the president of Pitch, whose software we have been using all along through here. Agostino is our academic chair. In Italy, Zuquan Lee is the technical chair. He knows more about this than any of us, and he is a NASA employee at Johnson Space Center. Nikolay Tomov is our operations chair. Nikolay is been dragging a lot of us elder folk into the modern world about how we are sharing these things, how we're looking at things, how we're describing this, and he's sitting in front of the feed to be able to go broadcast this out on YouTube as well for a lot of the folks that wanted to be involved to be able to go watch. My name is Mike Conroy. I'm the architect. I write a few things down, and all these other people do all of these fantastic things. Damon Nelson has been helping us with the website, the outreach side, kind of explaining to us ways to, again, go move our world such that it can be more accessible. I don't see Paige on the list, but Paige Whittington is also at NASA. She's been stepping in and leading and helping when Zuquan's been called away, and the same for Chetan Patel. Chetan has been a part of SEE a number of times and has always stepped in and helped us go do the types of things we're looking at. And again, Zach Cruz has always been there watching. He was there with us in the very, very beginning and keeping us on track on the types of things that we have to go do and the types of things that we have to go build. So these are the people that are helping go hold this together, or at least the top layer of folks that are helping us hold this together. There's a lot of people, all of the faculty, all of the team leaders, all of the people that down working that also make this very, very possible. And I wish to thank them very, very much. This would not be possible without the people on this slide and many, many others. We've also got companies that have worked with us to go help us make this possible. CISO was there at the very beginning. This was, I believe, started out as Zach's response to a challenge presented by CISO. Pitch has been with us all along. Bjorn has been developing a tutorial that everyone can go use so we can all go learn HLA from day one. MOC, of course, NASA, SCS, Society for Modeling and Simulation. All of these people have been a part of it, have provided funding for this, have provided tools for this. I'm with the Florida Space Institute down in the lower left-hand side of things here. Sakers helped us with the infrastructure a number of times in the back. GitHub has provided us resources to go use, and a relatively recent addition is the Combinize people that are helping with a distributed project management system. All of these people are a part of what makes this possible, or makes it easier for us to go do. We're talking about modeling and simulation. One of the things to feed into that, or one of the things to go share with all of this, is what is a model and what is a simulation? We talked to people over a number of years, and the definition changed, and I was challenged by a leader a while back to come up with a two-line definition of a model, two-line definition of a simulation, and I had to get everyone at Kennedy Space Center to agree to it. It took a while. What we came down to is we model something. When we're building a model or we're creating a model, we wanted to represent a thing that we want to study. And we put as much detail into that model as we need for that study. When we look to simulation, we want to represent how that thing behaves. How do the things that we want to all pull together pull in such that we can see how they behave with the other types of things that are together. And we put in as much detail or as much complexity in that as we possibly can, or as is needed for that particular study. And then a key third step here is we look at the models, we look at the simulated behavior, we go make a decision. We decide something important, something that we want to go do. We decide what we're going to go do next based on what we learned. And a key piece of all of this is that we communicate the results of what we did. We write it down, we take videos, we share the videos, we do reports, whatever it is. We did some work with the model, we did some work with the simulation, and we go share what it is to represent the detail we put into the study, the effort we put into the study, and then we do it to also make sure that the results and the work that we did can be reused later. So somebody doesn't have to do the same thing over and over again. When we're designing large complex systems, this type of communications is critically important because there are many, many, many parts that are involved, and we want the results of the work that everybody has done to be able to be shared across the group so that larger groups of people don't have to go recreate the work. They can take advantage of the things that we have done. Several people that are a part of this have seen this graph. I stole this drawing about 3 decades ago. The person I stole it from freely admitted that he took it from his boss about 15 or 20 years before that. So this is a long-term problem in design, or it's a long-term representation of how design works. In the very beginning, when we're working, we've got pretty much, when we start a project, we've got all of our design flexibility. We can go make a bunch of decisions. And we haven't committed any of our resources, so we've still got our funding and we've got our money, but we're designing something so we don't really know anything about it yet. We don't have any system knowledge. As we mature through this and as we go work through these types of things, the things change. Just getting through the concept phase, just getting through a couple of pilots, just getting through a couple of prototypes, we suddenly have spent a rather large chunk of our resources that we had set aside for this. We've pretty much lost a lot of our design flexibility because we've kind of made some decisions, and the prototypes typically don't give us a whole lot of the system knowledge. So we still don't really know a whole lot about what we're building, how it's going to go work as a system, especially if it's a large system. And like I said, we've committed about half of our resources to a concept. We don't have a whole lot of design flexibility. This is a problem. This is constrains you on what you're going to go build, constrains your path to the goal, and constrains the types of things like that. The solution, simulation. This is why we're here. These are the types of things that we're doing, and it's kind of what we're looking at. And there's a lot of ways to go look at this. What you're going to see shortly is the methods we use for SEE. There's some other ways you can go look at this on smaller projects and pull it back together. But what we really want to do is we want to learn more. We want to learn everything we can learn very, very early in the project in this concept phase. We don't need a CAD system. We don't need a CAD drawing. We don't need a SysML model to go get rolling on things. There's no master equipment list or work breakdown structures. We haven't done any finite element analysis or anything like that. We're not doing those types of things. We're not designing something. We're just maturing a concept to kind of see how it works and then be able to use what we talked about before, share what we thought with a lot of people and let them go help us mature our concept to what it needs to be. So the product for what we're looking for when we do this type of work is something visible or tangible. Hey, this is what we thought, other than me standing here and saying it's about this big or it's going to move about like this or something like that. We need it to be in sufficient detail so that I can go communicate my ideas. And we need to be able to extend and go share and go move those ideas if we need to with a party of people that are going to help us make this better and better. And we kind of need it good enough to be able to go measure it or compare it or record it or go share it. So this is early life cycle concept development. This is the precursor to a lot of what we're going to go see here. But we need tools and we need the ability to go do these types of things. One concept is, hey, do we have a sketch? Can we go draw it? The old stories about designing things on the back of a napkin or a piece of paper are along these lines. But can we use this for the simulation stuff? And kind of no. On the no side is because it's not really tangible. I've got something coarse that may be sitting there. It's not really tangible, but may be able to communicate something. But you really can't integrate the drawing you put on this piece of paper with the drawing you put on this piece of paper with the drawing you put on this piece of paper. But it does communicate your intent, and it can be photocopied, take a picture of it and go share it. But it's really rather hard to build to a sketch. But it is better than me trying to go describe what is on this picture to someone. But it's at what we consider a cocktail napkin level of fidelity. This is you sat down at the table and you drew out what you were looking for. So a sketch, it's not really doing our simulation. It's not really doing the things we were looking at there. About a rendering, we've used art packages before. We tools like Maya, tools like in the graphics package. Can they help us communicate that and go do these things? What we end up looking at there is, kind of no as well. The image is not really tangible. It's a graphical image. It's in a lot more fidelity than the sketch on the previous page. But it doesn't let us move the things around that we want to do. We can't really integrate the graphics models or the things that generate images like this that well. Usually they're buried, or the relationships or how they look is a part of the tool, and the tools don't share that well. But it does communicate our intent a lot better than the drawing that was there, and it can be distributed and recorded. So that kind of works a little better. It's still very difficult to go build to something like this, but it is better than waving hands, and it has a lot more detail in it than the napkin that we drew on. But the data doesn't move around that much. We use some game type systems in here. The old Don tool was game-based tool, and we have other ones that we look around that we've done some things. So we start looking at, can we use a video game to go share our concepts, mature our concepts, and get people to go look at it? And there's really no reason not to. This becomes a very, very viable way to go do things because it does communicate the intent. It gives you an environment where you can go move around in it and inspect what's there. You can pull models out of it because models had to be created to go put into it. And the video games give us a way to share with our friends, go communicate it, and the actual activity of putting the concepts and the designs in the game gets us a lot further along the design process than really what you would think, because you have to go through several things to create those models and put them through. What we get out of these video games is something like requirements now say, hey, build something that looks like this, build something that acts like this. So I've got my model and I've got my simulation for the activities, and it supports different ways to go look at it and how to go start taking things apart, because you had to put the models together, put them in there. But this gives us some skills that requires some skills that aren't really in our engineering curriculum. This is where we take the STEM work, the science, technology, engineering, math, and we start looking at the STEAM concept, which is science, technology, engineering, arts, and math. And we've got the artistic elements, and we've got video game production, we've got things like that that give us a ways to go look at things. And we can learn a lot about, say, this system right here when we go put it in a game and try to go use it. The challenge we've got is space is not really about one thing. We mentioned multi-generational projects. These things are hard. There's a lot that you have to go do. There's a lot of moving pieces that come together. And really, we start projects that we know in our hearts that our children are going to have to go finish for us, because we're not going to be around quite that long. So we can do these sim activities. We can do these types of things with a video game, but we've got a little bit of hope. But for the challenges that NASA and really the planet is looking at, getting the moon and getting onto Mars, we need a little bit more. Space has a lot of physics that are hard. Space has a lot of pieces that are hard. The games can do a few of them, but to do a lot more, you need a big group of talented people. You need a lot of folks. You need developers. You need mentors. You need sponsors. In the industry side, you need experts in the field, tutors. We need teachers. We need leaders to be able to get people to be able to go do this. And we need the right tools, which are the simulations, the models, the math, how we're going to go communicate, how we're going to work together, and how we're going to do all of that. So to do space, to do challenges and work that are like this, we need a lot of things here. And these are not skills that you can go find in a lot of locations. There's small groups of people on this planet that are able to go do this types of work. And when they work together, they all bring all of their capabilities and all the types of things that they're doing. And the good news is we can go do this. Today I'm looking at the list right now of 45 people. There are several dozen talented individuals that can show us how to go do this, demonstrate that has been done, demonstrate ways to go build systems this way with people from all across the planet and people from all across time. When we get to the ideas of these projects are going to be finished by people that aren't in this call. I'd like to go turn this over at this time to Zuquan Lee from NASA Johnson Space Center. He is the technical chair for SEE 2023. And Zuquan is going to show us what's been done here and show us how to go build things and how to go put them together and how to go colonize the moon and then ideally move on to Mars. Zuquan.
Thanks, Mike. Hello, everyone. I think many of you have known me from the Weekly Tech Up. I'm Zuquan Lee. And we also have Paige Willington and Jim Patel with us today. Three of us, we work in the simulation and graphic branch at NASA Johnson Space Center. We support many simulation developments for future NASA missions, including the lunar terrain vehicles, human landing systems, and gateway station simulation for Artemis and Gateway program. A little bit about myself. My involvement in CE, I started as a NASA intern back in 2011, working on the very first CE that back then we call CISO Smackdown. And I have learned so much from the project, including building a lunar shuttle federates using NASA simulation tool called Trick and Trick HRA. And the best part, I think, from that experience is that I have the opportunity to work and interact with teams from other countries on developing on the federation and execute it during the final event in Boston. And then after the internship, I formed a team at my university, Penn State, and continued participating in the project for about 3 more years. And then I started my full-time career at Johnson Space Center. And in 2020, I had the opportunity to come back as a technical chair It has been a great experience with working with the students. And this year we also have Paige Wellington and Chetan Patel providing support and guidance to the students. So I really appreciate for all their help. Before we start the team presentation, I also want to thank all the students for all their great work that they have done this year. All the team have overcome many challenges and worked together to design and develop their model and federates. So without further ado, I will start going down the list and call each teams for their team presentation so we can learn more about the work they have done this year. I'll start with the active team first. Let me share my screen here. The first team up is Brunel University.
Give me just a second, Juquan. This is Mike again. If you've got your camera up, the tool we've got forces all of the things that Juquan is going to present to be smaller. So if people haven't muted their camera, if you can, please go ahead and do that.
Hello,
You guys see
everyone.
the point?
Thank you for sharing. Zaquan, is that okay if I share my slides? There have been tiny bit of modification. I added one last page for future direction. Is that okay or not? It's fine either.
No problem. Go ahead and share your screen.
Okay, thank you. I hope everyone sees the screen.
Yes, I can see it.
Great, thank you. First of all, thank you, everyone. This has been a great experience. I go quickly to the presentation because I know we have not a long time for the presentation. Sea exploration experience, everyone knows what that is. We go to our next page. Little bit about us at the Modeling and Simulation Group. We conceptualize, design, implement, run simulations, discrete event simulation, agent-based simulations, distributed simulations, continuous simulations, and Monte Carlo, and many other simulations under supervision of Simon and Anastasia. We have other team members, Nora, Arindam, and myself, Maziar, and very happy to be here. What we have next page. So we came together to contribute to the project with building a facility on Moon that has an outpost. Initial idea was that we have many outposts, but the final project, we end up having 2 outposts with a rover added to the scene, and a control panel at each outpost that can control the rover movement. This rover can be used for passing logistics or carry passengers from one place to another place. The idea was that we get the kind of the interaction work between the panel and the rover and the users with the panel. So it was more like a very foundation project to start building upon, maybe in future, and we have defined data elements and interactions, and the tool we have used. I can go to the actual next page because there's also a video that takes about 3 minutes. I go quickly through this presentation. We actually adopted a top-down implementation approach and bottom-up design, kind of starting with Eclipse, going to Unreal Engine. Also used Unity to design our 3D models and fix some mesh 3D models that we had, but we needed to modify it a little bit to fit into our Unreal Engine. And we used the Pitch HLA connector plugin to connect everything to our RTL. The interactions are between rover and its control panel and users with the game engine. Also, we have other data elements like that landscape, trains, 3D positions, which are in terms of coordinates and physical parameters. I'd like to share with you what we have done through this video, and hopefully I can little bit commentating on it while it's being played. So I'm gonna go ahead and let it play. So in this first few frames, we see that we have created a federation, and with federates connected, and this shows the time advancement. All of them are actually were quite good. We never had problem with the time. We have two users kind of acting like client servers in the Unreal Engine plugin, but here it's connected as a federate, and the lunar vehicle that or rover that moves between two locations. And here is the landscape of the sea base, and we have here two users connected as a two federates on left side and right side. Here it's called clients, but exactly it's the same. Is each user is actually a federate, and also the vehicle is also the vehicle is a federate too. So first we start with just waiting for the HLS to initialize, and we have the on left side waiting for the user to go towards the control panel, and it says press R to call back the rover. So rover starts moving towards the outpost of A, and we just didn't complete the whole journey because it takes lots of time. Rover moves very, very slowly, and goes to the other button and sends the rover to the outpost B, which is just behind the rover. And we complete this with the user to also carry out the same duty, going to the, now we switch to the right hand side client 2, second client, or federation, or user. And here again test the control panel to send the rover, call back the rover to outpost A. And complete the process with sending the rover back to where it was. We're hoping that we add more rovers to the scene and more interactions. So this is only one rover. We're hoping that everyone can add rover or users. Also, I believe this is finished. I go to the next page. So let's just go to the a lot of challenges actually between these models. For myself and my team, the technology was new, visualization also, RTI. We had to learn very quickly and new skills with the visualization, 3D models, and simulation. Also, the interaction in the Unreal Engine caused a lot of problem at the beginning, especially through the plugin. The performance, we are exactly on the edge of a normal PC breaking. So we are hoping to, in future, to reduce the complexity. In RTI, again, the same thing with interactions. The design quickly becomes very complex, so we have to keep the complexity down. Also, the integration. So overcoming challenges is just resilient, continue testing. Yes. Anyone has any question? Okay, I just carry on. Effective communication, clear goals, defined responsibilities, and just testing and making sure the design has the quality that we are looking for. Future directions is that we add more outposts, building upon current infrastructure, focus on performance enhancement, reducing the design complexity, use different visualization engine. Our goal definitely would be to design whole thing using Dawn visualization. We had the attempt with that, but unfortunately we needed more time. Conceptualizing and implementing more interactions, collaborating with more teams, encouraging more students to join us. It was a great experience. So and have fun doing it. Thank you very much again from myself and the team for fantastic experience, and we hope we continue collaborating again in coming years. Thanks, everyone.
Thank you, Marcia.
Thank you. I stop sharing.
Okay.
Okay.
Next team, we have Embry-Riddle, Aeronautic University. Let me go ahead and share the screen. See if I put in presentation mode, can you guys still see it?
Yeah.
Okay.
Oh.
Oh, sorry. And now it's on slide 2. Just wanna do a quick test to make sure once I change the slide, you can still see it.
Yeah, we can still see it.
Okay, perfect. Let me go back to slide 1 so you can. Right.
Can you guys hear me?
Yes.
Yeah.
Okay, perfect. All right. Hi, everyone. My team and I are part of the Embry-Riddle Aeronautical University Worldwide Campus. We are participating in this event for part of our capstone project for engineering. Next slide, please. We have a total of 15 people for our team. From there, our team is broken down into 3 different groups. We had the HLA group, the graphics, and design team. Among those members, we have Munatsi, Amanda, Forrest, Lynette, Jacob, Ari, Ryan, Carl, Gerardo, myself, Kevin, David, Brian, and our professor. We also have Justin, who's not pictured. Most of us are full-time students with full-time jobs as well as a full-time home life. What you see here, we've completed in just 16 weeks. Next slide, please.
Traveling habitat. It is a vehicle with 400 cubic meters of living space. It is a 1200 kilowatt battery pack to power the life support systems, the berthing mechanism, the airlock, and the control and communication system. Next slide, please. This is our model on MATLAB Simulink. We're simulating the temperature, the number of astronauts, oxygen, and CO2. The input to the simulation will depend on the number of astronauts, which will affect the oxygen and CO2, and collectively affect the charge of the battery. We will also see the temperature fluctuating from day and night, and when the CO2 is too high, it will illuminate the warning light. Next slide, please.
Hello, I'd like to introduce to you the Water Extraction and Transportation Bot, or as we call it, the WET Bot. We designed the WET Bot using existing technology of the lunar rover, but converted it into an autonomous vehicle equipped with a microwave emitter and extraction tool, or MEAT for short. In lab testing by scientists Edwin Etheridge and William Cockler, they were able to extract 85% of the water trapped in their lunar regolith test. We believe this will be the most efficient method for water collection on the lunar surface. To collect this water, however, we need to be able to safely store and transport it, which will be done via the converted lunar rover. The lunar rover is already proven to be able to navigate the lunar surface, but it is important to measure this movement and its power consumption. Next slide, please. To demonstrate this, we used MATLAB Simulink software to control its movement with inputs of steering torque, thrust force, time, power, and state variables to create this plot that illustrates the path of the rover and calculates the power consumed. To thrive on the moon, astronauts need tools that are reliable and efficient. We believe that the WETBot should be a part of their toolbox. Next slide.
We have also designed a telescoping spinning disc that utilizes the Coriolis and centrifugal forces to launch a 10-kilogram payload from the surface of the moon to the surface of Mars with an escape velocity of 3 kilometers per second. We did this so we can support future Mars missions as well as additional missions on the moon. And the proposed interactions is that the spinning disc has a loading mechanism that you can see on the top of the disc. It takes in the lunar regolith provided by the wet robot and can launch it to another team on the moon, or again, as I said, to Mars. Next slide, please. We also utilize MATLAB and Simulink using state space models and the Monte Carlo analysis in order to determine and model system behavior, as well as create a simulation of the launching mechanism. You can see here on the bottom right corner is a black box. It really should be a little bit easier to see. I do apologize, but if you look closely, there's a small, very green bar that does represent the launch spinning disc. And what happens is when you play this, that green bar spins as it was the disc, and there would be a yellow ball that represents the payload. And based on the analysis, the Monte Carlo analysis, we were able to predict the launch angle, and this simulation shows that the payload will be launched at the same launch angle determined. So we can accurately predict where that payload would land. Next slide, please.
With regards to the lessons we learned while doing this project and things that we would suggest for future groups, one of them is to learn Java beforehand. Embry-Riddle is a engineering school mainly towards mechanical, electrical, and aeronautical engineering, and so programming is not a big part of the curriculum. Learning that in advance will definitely help the groups. Ensure that all your files are up to date and applicable to the current simulation and the C event. There were some big changes that were made in 2022 that unfortunately we weren't able to integrate into our simulation. And if we had verified that beforehand, it wouldn't have been as big of an issue. Communicating early and often with the other students, especially in other groups, being able to complete interactions, it's a whole lot easier to build those interactions into the program in the beginning rather than trying to add them in at the end. And if you can communicate with other groups and determine what you want to do, it's a whole lot easier to do it in the beginning. And the last one we would recommend is to start off as a passive participant. We jumped straight into an active participant role this year, and so we didn't have the background of files and the background of information that some of the other groups that have been doing this for a while had. And basically we ended up doing 2 to 2.5 years worth of work in the 16 weeks since this started. On behalf of my group, I would like to thank NASA and CISO, along with Pitch and all the other companies who made it possible for us to participate in this event.
Thanks, guys. Look forward to see your Federation action, the Federation execution. You guys have done an amazing job as a first time participating in this and got things working and interacting. Right. Please stop sharing here. Okay, next one we have IMT, Mine's Alice team.
Hello? Can you hear me?
Yes. Can you see the screen slide I'm sharing?
Yes. Yes, I can.
Whenever you're ready.
Okay. Okay, I'm ready. Can you give me the control of the slides, please?
Sure. Just let me know.
Okay. Okay,
when
no
you want
problem. No
to
problem.
go to the next slide.
No problem. No problem. Thank you, Zukon. Hello, everybody. This is Alice team, and we are representing IMT Minales Engineering School in France. We are student in the prison department, aka Industrial Performance and Mechatronics Systems. Next slide, please. So I would like to talk about my team first of all. On the right, it's my teammate Kanta, and on the left, it's me, Enzo, speaking. As you can see, we are a team with two members, but for sure we had the supervision of our supervisors, Professor Gregory, Mariam, and Francois, which I would like to thank a lot. Okay, so when we started to work with the project, the first thing was to find what federate are we going to develop. It didn't took too long to think and to analyze that a very important federate and object in the moon for the development of the human life in there is the oxygen, for sure. So for that reason, we created the oxygen production system. As you can see on the picture, this is our object, our federate that we have created, and it is it is composed of two main reactor, two main components, the reactor and the electrolysis. First of all, I would like to explain that we create oxygen from the Luna soil. In the beginning, the Luna soil goes to the reactor when we extract from it the water and the element that comes with the Luna soil. After that, the water goes into the electrolysis, which is the building behind it, where from there where the water is when from the water is extracted the oxygen and the hydrogen. The hydrogen goes back to the reactor because it needs for its purposes, and so we have left the oxygen which can be distributed to the other federates and to other teams. For this project, we have actually used some tools, very important to mention, which is Blender, SolidWorks, Eclipse, Pitch, different types of Pitch RTI, Visual Studio, Developer, and Unity for sure. Since we have a federate, we absolutely need some interactions. And in here in this slide, I have shown metrics which represent which type of interaction we are going to have in our system. So based on the other baseball card and what I saw, I think that the UCF team is a great federate that we can interact with because they have the solar panels which are very needed for creating the electricity. Another team is the NVNA team, which has some laboratories and buildings where we can send them our oxygen that we produce. And two other teams, we have ERA4 and GEN, which have boats and rovers, and this is very important for us because they can give to us Luna soil or water so we can we can continue with our procedures of oxygen production. With all the federates, we subscribe to them, we publish, everything is shown in here, and yeah. Next slide. Since we did all this work and all this project, it was the first time for us having dealing with software engineering, and for sure we had some problems and we have to find some solutions. First of all, the first thing that I have to mention it is we had to interact with different students from all over the world because to communicate and to find the reason for our problems that we had during our work. And for sure, this was a part that we had to pass. It was a problem that we had to pass. Another thing is it was our first experience with distributed simulation with HLA. We had to read some documents. We had to get prepared to try to understand how it works. And for sure, we had also to work with different software so we can create our 3D models or to make possible to have interactions with other teams, etc. So we have your Blender, Unity. Next slide. And in the end, during all this project, we have learned very important things. One that I really like is that we gained some knowledge on space exploration, which is something that I really like. For sure, we had to master some CAD softwares. Like we started actually to create our 3D model in AutoCAD in SolidWorks, and after that we placed it into the Blender and in Unity. So we had to master all the softwares. Another thing is that we have to improve our skills in Java using Eclipse. In the beginning, personally, I didn't have any information about Java programming. My colleague was in the same situation as me, more or less. So we had to pass this difficulty and try to learn and be more experts in it, I can say. Another thing is that we had to use speech to make possible the distributed simulation with HLA standards, which also is something I think very useful for us. And something that I really like to mention and I really like to emphasize is that is the teamwork. The teamwork was very important for us, discussing with the other team, discussing with each other a lot, with our supervisors, and I can surely say that teamwork is key. And in the end, I would like to share my 3D model, final 3D model that we have. We will see this later in our simulation part with my colleague Kanta. And next slide. Thank you very much. Merci beaucoup. Faleminderit shumë, and see you in the next mission.
Thank you, Anton.
Thank you.
Nice work. Stop sharing here, and we go to the next team. We have Naval Academy of Bulgaria.
Hello everyone, give us a few seconds for us to join the screen to Teams. So can we present from our computer?
No problem. Yeah.
Okay, I have one more thing to ask. Should we do our visualization in done after the presentation or in the later session as shown in the draft?
It's in the later section when we do the federation execution. So I'll ask everyone to join, and then we'll circle back to each team. I'll call each team, and you can do the demonstration.
Oh,
yeah.
All right, so I'm now starting the presentation. We are the team of the Naval Academy of Bulgaria, and we're presenting to you Project LunarTech, short for Lunar Research and Navigation Technology Center. At the head of the team are Associate Professor Evgeny Andreev, Associate Professor Vesel Karadeva, Head of the Planetarium of the Naval Academy, and Associate Professor Maria Nikolova. The following student members on the screen contributed and created this project through research, concept art, scripting, and 3D modeling. Project LunarTech consists of the following federates and components: the base, which is constructed of habitable domes divided into categories depending on their function, a habitat rover, which transports astronauts and pressurized cargo outside of habitable spaces, an explorer rover that is an automated device for scanning and analysis of the lunar surface. It works together with our hopper at the bottom, which is an automated vehicle that transports heavy and pressurized cargo and travels to difficult to reach terrains. Also, we have a gateway that is a link to the Artemis mission, and the capsule, also part of the Artemis mission, for transporting and housing astronauts, being a compartment of the gateway. And also rockets, which are optimized and selected for missions between Earth, the Moon, and Mars that bring us higher efficiency for the travels. This is our base camp. It is located in the Nobel Rim, near the southern pole of the Moon, and the base is sectioned into 3 parts. The first layer is the core of the lunar base. This is the logistics center. It governs the main functions of the base, and this is where decisions concerning missions on the Moon surface happen. The second layer is reserved for laboratories for 5 main scientific research divisions: geodesics, biological research, astronomy, engineering, and also advanced research. The third layer is the habitable spaces for permanent inhabitants, with 3 biospheres reserved for the permanent astronauts, and 1 specialized as a training center, and also another one for commercial purposes. The purpose of the Lunar Tech Base is to contribute to exploring the lunar surface with the goal to create a full resource map of the Moon, and after that to extract resources from the Moon, making the lunar settlements less dependent on Earth resources and reducing costs. Lunar Tech's laboratories will examine the effects of the lunar environment on materials extracted and manufactured on the Moon, settling the foundations for future outposts on Mars. We will also utilize the perfect conditions for astronomical observations on space weather, on near-Earth objects, and also objects in deep space. And not to forget, another core mission of Lunar Tech will be promoting international cooperation and scientific exchange. Back to our mission assets. This is our Habitat rover, which will be the main vehicle for transporting astronauts and scientists and also large amounts of pressurized cargo. It is equipped with tools for repairing and maintaining critical components of the lunar base and will serve as a communication relay when in need for extending radio access range. We also have 2 pilotless vehicles that are designed to be semi-autonomous, working together, the Explorer and the Hopper. The Explorer rover will be equipped with terrain scanners and scientific tools for soil analysis. Its purpose being to explore scientific routes, leaving containers with samples for further experiments at the laboratories, and at specific locations at the route where the hoppers will go and collect the samples and bring them to the main base. The hopper will navigate by making partial jumps in low elevation orbit to the container left by the rover, and collect samples via a robotic arm. The main aspect of the hopper is that it is extremely mobile and does not get influenced by difficult terrain. We have also included, for transportation of astronauts and research and scientists to and from the Moon, we have rockets, which will be optimized depending on the specific mission and route. An intermediate transport vehicle will also initiate transfers between the lunar bases and the gateway for minimal cost, since launches from the Moon to Earth and Moon to Mars are more efficient than Earth launches due to the Moon's weaker gravity. This is also one of our components, the human transport capsule, designed as a module of the Artemis orbit station. It serves the purpose of housing astronauts on longer travels, and is also a module, one of the compartments on the orbital gateway. And finally, to link Lunar Tech to the bigger picture, we decided to utilize the orbital gateway as a core part of our mission assets. It represents the Artemis mission orbital lunar gateway, which is very important for further missions and building sustainable colonies on the Moon. These are the features used in the technical execution of the project. We included the method we created for rotating objects based on criterions that we developed during the previous year of Simulation Exploration Experience program. And we also, this year, developed our own specific pipeline for adapting 3D models to DOM. These are the tools that we used, mainly DOM, Photoshop, and Blender. Our visualization is inside of DOM, so I guess you will see it later. Thank you for your attention.
Thank you. Thanks. Now next, go to next team. Have UCF base operation.
Zakun,
Yes.
this is Damon. Do you know why that bar is appearing across the bottom with the timeline and that sort of thing? I don't think that's coming from my computer. I think it's elsewhere. And sometimes it blocks part of the slides. I'm trying to capture a few images for recording our event today.
Let me share the screen again. And I don't know which bar you
It's the Teams bar showing the muting of the microphone and enabling the camera, etc. I don't think it's on my end. I think it's the presenter having the mouse in the middle of the screen or something like that.
that could be me. I may have my cursor hover over that. Can you see the screen now? I'm sharing the PowerPoint. I'm sharing. Do you still see the bar?
Yes, and it may be on my side, so I apologize if that's it. It comes and goes. It's hard to figure out.
No problem. Yeah. So if you are muted and if you are talking or if you have some sound on your end, and it will pop up a window saying you are muted. And
yes.
You can X out that. You can close that window. You should be able to. All right, let's go to the UCF base operation team, and we change this to a presentation mode.
Okay, let's start this. Hello, everyone. We are UCF base / operations. We are doing this project as part of our senior design. My name is Ryan, and next slide, please. Yeah, my name is Ryan Enriquez, and I am part of my role is part of the setting up the pitch infrastructure in HLA, as well as some aspects of model object design.
I'm Alex Goen. I was part of the object design and modeling as well as the pitch infrastructure in HLA.
I'm Sean Hurley. I was in charge of object design and modeling.
And I'm Kevin Finley. I was responsible for project management and systems engineering.
Not present. We have Kevin Kant, who helped design the web page in the front end. All right, next slide. So some of our goals for this project is, unlike other SCE teams, it's our responsibility to set up an infrastructure of which an environment in which other SCE teams can host their federates on in the simulation. So to do this, we need to set up an infrastructure with AWS. We need to build a web app that allows for easy VPN registration, so participants can log in their federates to the simulation. We obviously need to set up a simulation environment for the event. And in addition to that, we also designed object models for our moon base. and we need to ensure that these simulations are adherent to SE standards. Next slide, please.
So just to go over the web app that we built, so some of you probably have been to it. We bought a domain, simulationexplorationexperience.com, I believe. And the web app allows you to create an account to get VPN access. And so some of the technologies here are listed that we used to build. So we used, React JS on the front end, and we leveraged a lot of Amazon Web Services, serverless functions like Lambda, and then their database technology, DynamoDB, as well as like S3 to store the application. Next slide. So just to give a high overview of the infrastructure that we built out. So we had to create a server to run pitch RTI. So we had a server where the remote RTIs could be ran. That application didn't really have a notion of authentication. So to kind of provide security, we wanted to have it on a private subnet, and then you access that server via VPN. So we built two EC2 instances, one for OpenVPN and one for the pitch RTI. And we threw that in a virtual private cloud and created the security groups to allow access properly from the public subnet to the private subnet once you're connected to VPN. So some other technologies in Amazon that we leverage were CloudFront, Route 53 for DNS, Lambda functions, DynamoDB. As I mentioned, when you register on the web app, you create a username and password, and that password is hashed with bcrypt algorithm and stored in DynamoDB. And then when you connect with OpenVPN, it validates that hash using username password authentication and allows you onto that VPN. One of the cool parts about the infrastructure that previous teams didn't do previous years, we decided to use CloudFormation templates. So all the infrastructure is written as code and stored in GitHub so that future teams can spin the same stack up really easily, since all the infrastructure is written as code. Next slide, please. So yeah, just kind of some of the stuff I already alluded to. So some DevOps and the CloudFormation templates, as I was mentioning. So we had full CI/CD automation. So anytime we worked on the web app, we would push code, review it, and it would automatically build and deploy to the proper environment. And then the AWS infrastructure, which I think was a huge win for this. So moving forward, all that infrastructure is defined in those CloudFormation templates and can be easily spun up in the future. Next slide.
Right. So the web app was really designed as a one-stop shop for all of the SEE applicants, where they could register for the VPN as well as have all the resources required to them immediately there and accessible, such as guides for setting up the VPN and guides for setting up pitch and different interactions. So um, really, it was just to allow all of the SEE participants to have access to that easily, and it was designed utilizing NASA's Web Design System standards and a bunch of different things from them. Next slide, please.
So once participants are registered in our web app, they can then use an OpenVPN client to connect to the server pretty easily. We wanted to make it simple to use. It's a custom URL to import profile. As Kevin mentioned, we have username, password authentication, but yeah, it's just easy to use, and so that any team can easily connect to the server. Right. Next, please.
Okay, so this was one of the federates we were designing, which was just a launch pad. Just the baseball cards we used in the SEE event. You can go to the next slide. This was the launchpad walls, which you'll see in our interaction matrix. Like it's based off the position of where the launchpad is, so that they're in relative position in wherever it is. Next slide. And this was the living quarters, which we were we were having interact with the other UCF team to basically work with their solar panels to get power to it. Next slide. This is the interaction matrix we made. So as you can see, the solar panels was to interact with the living quarters, while the landing pads, worked with to be adjacent positions so that the walls will be maintained around the landing pad. Next slide.
So this is just a quick slide to go over some lessons learned from the web app and VPN. So one of the things that we wanted to do to allow unlimited people to connect without paying high cost, we wanted to use the open source version or the community edition version of OpenVPN versus the paid version. So that allowed us to have unlimited connections and not incur any additional costs. There were some difficulties just installing that and configuring it because it wasn't a SaaS product. You had to actually install it, compile it, configure it, and write some scripts for it. So it was a good lesson, but I think it took a little bit more time, but in the future, it'll make things a lot easier. Next slide.
So some of the lessons we learned when setting up pitch. So some successes we had is we had a lot of support group as part of SE event, and the initial installation was pretty simple and quick. However, it does use pitch uses a legacy Java 1.8 version, which did
fucking Confederates.
which did take a while to get used to. Also, the license that we need to actually install Pitch to take a while. And Pitch was not necessarily designed to be working with a VPN, but we still managed to get around to it. Okay, next slide, please. So some of the lessons we learned for a federate design and setup is that our models were easily implemented, and we were able to look through plenty of documentation from previous SE years teams when designed our federates. Our difficulties stemmed from not getting used to the XML metadata, and we had initial trouble initializing federates on the VPN. And that will be it for our presentation. Thank you for listening.
Thanks, guys, and
Thank you.
good job in setting up the infrastructure for the event this year. Thank you. Next one, we have UCF Moon Mars team.
Hello, can you hear me?
Yes.
Okay. Hey, everybody. We're the SE Moon Mars team. Next slide, please. My name is Alec York. I'm the project manager, and I've worked on federal development and testing.
I'm Will English. I worked on federate development for the Reflector rover federate.
I'm Lewis Nye. I worked on federate development for the solar panel.
I'm Richard Carter, and I worked on the Reflector rover model, and Noah Reynolds couldn't make it here today, but he also was working on the model development, and he did the solar panel.
Next slide, please.
So here you see our baseball card for the vertical solar panel. and it is built to take advantage of the horizontal light that is cast over the south pole of the moon. And you can see some of the intended interactions like supplying power to nearby entities, and it also can receive sunlight to then turn into power to give to those entities. Next slide. And here's our baseball card for the reflector rover. This was developed to kind of fulfill a support role for the solar reflector, or the solar panel, and it was intended to be able to climb on top of high locations to reflect light down into dark areas or directly at solar panels to keep a constant supply of electricity and sunlight going. And then you can see some of the intended interactions there, like charging at the station itself, moving around, getting an illumination command, and it also can support different exploration missions, like say a cruise going out into a dark area or looking down into a crater. One or a fleet of these could come up and assist those with visibility. Next slide.
This is a graphical representation of what our interactions are supposed to look like. So as you can see, the reflector rover is supposed to redirect light to the solar panel. The solar panel receives light from the reflector rover. The solar panel is also intended to recharge the batteries of the traveling habitat as well as the wetbot. Next slide, please.
So some of the challenges that we faced starting out, it was a little bit overwhelming going through practically a decade's worth of code and figuring out what is working and what's not and what's been replaced. But after a little while, it became clear what the current stuff was that we needed to be paying attention to. We were a little bit confused at first by the GitHub file structures that we had to look at, but we had some previous SEE participants at UCF who could help us out a little bit with that, which was very helpful. We also found it challenging to test our federate interactions because we felt that we had succeeded, but we just weren't 100% sure that everything would run smoothly in the end. So that was a bit of a challenge. And I think that's that. Next slide, please.
With regard to lessons learned, we now have an understanding of HLA architecture, which is an industry standard for the regard of simulation, and we've also been able to touch up on our Java skills. We've also been able to have a couple of our members get quick regards to learning through Blender and 3D modeling, and also how to work with a runtime infrastructure. And then we've also understood the importance of documentation, and will take great effort in providing documentation for future teams to start off on a better foot for next year's SEE event. Thank you.
Thank you. Great work. Okay, we do have one more active team. It's Genoa team, but unfortunately the students is on travel for conference this week, so they were not able to be with us today. I do want to share their baseball card. So what their federate provide is a autonomous rover that that's deployed to survey the lunar surface for water and minerals. And you can see the tool they use is the Java to develop their federates, Unity for visualizations, Blender for the 3D models. Okay, now let's move on to the passive team. This year we have two passive teams. We'll start with Ascens from Brazil.
Hey, Zaquan, I'm here.
Hello, Pam.
My stream?
Sure, yeah, if you want. Go ahead and share your screen.
Are you guys seeing?
Yes, I can see it.
Okay, so before we started, I want to ask you if we are going to have a time to show our programming on Unit.
Are you planning to join the Federation in the later section?
what it's what it's what better if you want to do after the presentation, we can do it.
Sure. Yeah. Yeah.
So, good morning, everyone. I am Pamela, and I am representing Facens from Brazil. So, okay. Today, we are going to talk a little about our team goals, our federates, our team, and some challenges that we have faced during the project. Simulation says a lot about our future vision for Artemis project. As our main goal, thinking about sustainability and mental and physical health, we created a basis on which we can think on this compression of the astronauts and in the advance of the science outside our planet. So we have made a federate, and Luke, is going to talk a little about it.
Hello everyone, my name is Luan Kleber, but around here everyone calls me Luke, so we don't get confused with the other Luan who does programming. I'm the modeling leader here, and I'm going to talk a little bit about our project. Our federate this year was inspired by a native bee from Brazil called Trigona, which can live in any environment with its community regardless of circumstances. With this, we created the Trigona base, known as TRIA, where the focus is to integrate within a lunar environment several research and leisure centers for astronauts. Showing the design on the outside, we can see that it integrates with our project last year, the sunflower, where they are petals of solar plates that accompany the sun. So there will be no lack of energy within the research and leisure centers in Trigona. Going a little deeper into the research, we see that when an astronaut is selected for the mission, he demands a lot of mental and physical. So in our brainstorms, we think about the area of decompression, where we bring Brazilian characteristics within the leisure environment, because we want to bring Brazilianness in a fun and interactive way to everyone who is in Trigona. And all of this stuff we are made with Blender and Photoshop. Our interaction, unfortunately, we were unable to reproduce it in Dawn, but to show it to you, we made a junction of the 3D models where we join the wheat with the sunflower that generates energy for the entire base and research center that includes it.
Speaking now a little about the challenge that we have faced by the team, our biggest difficulties were born with the lack of the intimacy and knowledge of the HLA architecture and the pitch development platform. Still, the team received the new members this year, so everyone on the team needs to go through a learning curve so that everyone can get in the sync and be able to develop the entire solution on the top of the pitch platform in HLA actor. For distributed simulation, so we had an elaboration of plan B so that then we could have our project considered finalized, being able to deliver the way of a visualization of our project, even without being able to simulate literally using the DOM. So we use a theory in our advantage, applying our model, interactions with each other as our last project, as we show it later that Luan shows us. Remembering that overall, all the coming challenges of the team, not leaving the learning and fun in representing Brazil in the same way. This year, we had the opportunity to expose our project to children and teenagers in Brazil on a day that we called Science Days, showing the resourcefulness of the work of our past federates and it was a unique opportunity in which we could be present face to face with future scientists, engineers, and programmers. So we could see the sparkle in their eyes. And we had a moment that we left a blank board on them to write what they would like to see on the moon as an inspiration for us on our next project. It was a super cool experience because a lot of interesting things came and it was amazing. So, coming to the end, now I would like to introduce our team. And this year we were able to get together and had the opportunity to expand our team full of skills and abilities that came to light. And with this, we worked very well as a team, and we hope to leave a good legacy of Brazil for everyone. And thank you, everybody. Is our member.
Thank you. Thanks, guys.
Thank you.
Great job.
Oh, can you hear me? We gonna
Yes.
show the Unity demonstration.
Right.
Oh, Kaique, can you share your screen, please? Oh, thank you. So, hello, I am Luan, and I have 19 years old, and actually I'm working with data science at Facens. Also, I'm studying computer engineering at Facens, and this is my first year in this project. The development of the project was very challenging, and I believe that I speak for everyone when I say that we learned a lot during the development. Before our demonstration, I would like to thank Zukun, NASA support that helped us, the professors, and the teammates from Facens. Now, our solution idea was already explained by Pamela and Luan. That is a lunar dome with some labs and Brazilian leisure space. Uh, to develop this idea, first our team worked with the 3D models using Blender, and after the completion of the 3D models, the team had some problems and difficulties with the pitch development platforms. For this presentation, we prepared this demo using the Unity. Unity works with C# language, therefore we export the 3D models to Unity and code a script to movement the camera by the space inside the unit. So in this presentation, this is a leisure area with some Brazilian features like a pool table, some sofas, and bookshelves. This is the sofas. Leaving this floor, we have other smaller domes to house the research labs. There is also a green area inside the dome just to bring more pleasant environment for the people who will live there. And just to finish, our next steps will be study and get more comfortable with HLA architecture. And with that, we can develop the idea with the pitch platform and the dome. So that is it. And thank you.
Thank you. Yeah, this would be a great place to live in on the moon. I'm sure it'll be a lot of fun playing basketball on the moon with 16G. Thanks.
Yes. Thank you.
Okay, now we go to the last thing we have for today's team presentation. We have Dobrik High School. we have anyone from Tobrick High School? Yeah, I do see your screen.
Yes, hello. Me and my team member Yavo, we are here to present the project.
Go ahead, what's yours? So right now I'm seeing the future work slides. Just want to let you know if you change
I
the
think
slide.
he has a little issue in the moment. I'm trying to get in contact with him because I cannot hear him speaking.
Oh.
So our teammate has a little issue with his microphone for some reason. It is not accepting when he's talking, so I will talk about the project. I'll be messaging him in the meantime so he can show the proper slides. Just waiting for him to switch slide. Okay, I will begin. So our project is ART, short from Asteroid Resource Transportation Systems. This is a project from our High School of Mathematics in Dobrich. Our team is made from Vladimir Dimitrov as a team leader and modeler, Javor Markov and me, Iveta Ivanova, as researchers, Pavlin Panov and Ivo Tsonev as developers, as well as Pavlin Petrov as another 3D modeler. We're just waiting for the slide to switch. We're having some technical difficulties with Java's computer. Okay, it changed. So this is a baseball card. We wanted a project to be with a few more parts, but due to that we joined it late. We couldn't really finish all of them. Our idea was to make a special project that could use a few space hooks that would be in the size of a satellite that would be used to collect meteor asteroids, which will be sent to a station on a close planet, most expectedly Mars. And from there, they will be sent to a special station from which we will use special space trains that will then lead the asteroids to Earth and will be extracted special materials from them. The purpose of this system is to gather the asteroids fly near the planets Mars and Jupiter. From there, they get transported by using space trains and elevators to be brought down to Earth for processing and extracting resources from them, as said in the baseball card. Until now, we could finish a few of the models. They will be shown in the next slide. This is our three models. We went for simple models until now. We're planning to improve them in the future. On the left, we have made a space chain model. We based it on the fast chains that we have on Earth. I believe they are called magnet chains. And on the right, we have an example, example of a space hook. We planning to work with solar panels for an energy source, and it to have a special hook that is going to grab the asteroids and then lead them to the station on the planet. We have a lot of things planned for the future. We are very happy to be a part of this project, and we have a lot of plans on improving it. We hope that in the next years that we're going to participate, we can improve our models to make the rest of the plant elements, to continue with our research and to collect significantly correct information, as well as making more interactions and be able to finish this project as good as we can. Thank you for your attention.
Thank you. Great job. You guys joined late this year, and this is you guys have done a very good job on putting things together. All right, that's all our teams, active and passive teams this year. We do also have a few observers this year, and hopefully we'll see them in the next year's event. I think all the teams have done an amazing job this year, and it's a pleasure to work with all of them. And I'm amazed by the work they have done, and their ability to learn HLA's concept and tools, design their federates for the scenarios, and also working on developing the federates and 3D models, collaborate with each other for interactions in such a short period of time. So let's give them a big round of applause for their accomplishment this year. And so I think we are gonna do a group pictures before the federation execution. So if you make, please unmute your camera. To change the beat. Okay, I can see we got 30 cameras loading here. Let's give other folks a few more minutes. Sorry, a few more seconds. And since we got our camera unmuted here, again, great job, guys. Nice work. Okay. All right, I think we got all the camera loaded. Guys ready? All right. 3, 2, 1, smile. Thank you. And let's move on to the next section, which is the federation execution. And we got 24 minutes left. I think we can do it. I would like to ask the UCF base operation teams to run the core federate, to bring up the central RTI and the core federate. Sorry about my cat.
It's running. Do you want us to share the pitch web viewer?
Yes, please.
Okay. Can you see my screen?
Yes.
Awesome.
So we already have the IMT minds. Alice means federate joined. Was this running since 10 o'clock today, right?
Correct. Yeah, we started at 10 when this started.
Okay, perfect. Right. So I'll call other teams and you can join your federates. And once all the federates join, we'll circle back to each team and you can, each team will have like 4 to 5 minutes, 3 to 4 minutes due to the time, to talk about your federates in a little bit more detail and demonstrate the interactions. Okay. So first, let's have Brunel University. Please join your federate.
We might have a problem. I'm trying to join, but I might need a few more seconds to make it done. Sorry. Is that okay if you come back to me?
Sure. Yes. No problem.
All right. Thank you. Appreciate it.
Next we got Amber Riddle, Aeronautic University. See the mining rover, the launcher, and the habitat. Perfect. And I believe that's all the 3 federates, right?
That is correct. That's all 3 of ours.
Right. Great. Thanks. And you have the IMT, Mines Alice team, 2 federates. Just want to check with you guys, are there any additional federates that you want to join? Or this is the 2 federate for this year?
Yes, Zukon, we actually have OOPS, the oxygen production system that we spoke, but to make more the interaction more visible, more possible, we decided to add the lunar rover, which we have modified, and we can send Luna soil or water to our main federate, which is oxygen production system.
I see. Got it. Thanks. Right, let's move on to Naval Academy team. Please join your federate. See the base, the mineral.
We're connecting, but we might need an additional minute.
Oh, who is that? Who is this speaking?
Academy. The Naval Academy.
Oh, okay.
Okay, we're done. We've connected.
Yep. I see your federate. You got the base, the capsule, the Explorer rover, gateway hopper. You got 2 hoppers, mineral and rocket.
That should be all of them.
Okay. Great. Thanks. Okay. Also, UCF base operation. I know you guys have your own federates, the launch pad, and other federate. Please go ahead and join those. see. 3 federates trying to join, but got resigned.
Yeah, just give me 1 second. I'm trying to get it back up.
Okay, while we're waiting for them, the UCF Moon Mars team, please join your federate.
Yes, we are trying to join right now. Just give us 1 second here.
Okay. Take a screenshot here. The landing pad and solar panel.
Yeah, the reflector rover and the solar panel are UCF Moon Mars. That's us. We just put those up.
Right now we have 20 federates, right? The Brunel UE plugin. Drop off.
Good thing you asked for more seats.
Yeah.
Okay, we have R3 up, which is the living quarters, landing pad, and landing pad walls.
The 2 federates, right? Steve Brunel, user 1. Okay. Let me take a screenshot here. Oh, while we're waiting for other teams to the other federates to be joined, we can actually start the demonstration with teams that is currently ready. So I'll just go down the list. If you want me to circle back to your team, since you're still trying to join your federate, just let me know and we'll circle back to your teams. So let's start with Brunel University. Are you guys have?
I might have a problem. Sorry to interrupt you. Go on. Sorry.
Okay. Yeah, I'll circle back to you guys.
Thank you.
Sure. Embry-Riddle Aeronautic University.
Yes, sir. I can show you if you'd like to unshare screen. So we have the Dawn software. You can see our 3 models are in there. Unfortunately, they have to be static because our movement isn't quite working correctly. But we have our mining rover, our traveling habitat, and then our launcher. We did end up putting it near UCF just for scale and to give people an idea of where it was. I would imagine our future groups will end up building their own little mini mine colony, but for now, just for ease, we put it near the UCF stuff. You can see, I don't know how well you can see, but this is the lunar rover console. It is receiving updates. Unfortunately, it's receiving so many updates, it's kind of going by quickly, but our interaction of it moving out, the longer lines of code that are going past, that's what those are, is it updating its position and moving away from the launcher towards the spot where it's going to mine. Once it gets there, it sits there and mines until it reaches capacity, and then it returns to the launcher, receives a new charge, and then goes back out again. And the launcher also does the same thing. You can't see the longer lines of code right now, but it updates itself with a 5%. Basically, the regolith gets dropped off at the bottom of the launcher. This updates 5% of loading capacity at a time, and then gives you the option to launch it once it has reached 100% ready to launch. Our habitat will be covered by Amanda.
I'm sorry, 1 second. I'm trying to share my screen.
Sorry, just one
Okay.
question. So
Yes.
the interactions of your federates, they are all working. So just the graphic is static, right? So behind the scene, the rover is moving and it's sending and receiving interactions and collecting the resource. Is that correct?
That is correct.
Thanks.
Can everybody see my screen?
Yes.
Okay, so mine is set up the same way where I'm getting so many updates from the other federates that you can't really see my code that prints, but my habitat is set with an original temperature and it loses a temperature 1 degree every 10 seconds. Once it hits temperature below 60, it stops moving and it starts heating up again. So the position isn't changing while it's heating up. The power and the temperature is displayed. When it's moving, it loses more power. When it stops and it starts heating up again, it starts losing more power too. And that's my federate.
Thanks, guys. Right. Let's move on to the next team. And Jacob, Amanda, that's great job, guys. And
thank you.
Yeah, especially this is your first year participating. You guys get all the way to join the interactions, join the federation, and have the interaction workings. This is amazing. Next we have IMT minus Alice team.
Yes, Zocon, if I can share my screen.
Sure. Yes. Go ahead.
Okay. Can you see?
Yes.
I need some time to run. looks like we are having some kind of a problem, which just happened now because it was working perfectly. Can we maybe join a little bit later, Zukon? This was very unexpected.
Okay, no problem. I'll circle back to
Sorry.
you.
Okay.
No problem. Next we have Naval Academy from Bulgaria.
Hello, we're up. We have focused more on the visualization side of the simulation, and once it loads up on our computer, we will share you the screen. I can tell you beforehand that we are going to do a walkthrough of the Lunatech base. And you will see that there are a few habitat rovers on standby for transporting people between the modules. The logistics center will be controlling an example mission on the moon surface that is directly aimed at exploring the moon and settling foundation for future missions. So here we are. This is the lunar tech base, sectioned in the 3 layers. The logistics center at the middle, the 3 outer laboratory, the 5 outer laboratories for geodesics, biological research, astronomical, engineering, and advanced research. And also you can see the 3rd layer with the 5 living space biospheres. After that, we can move on to the gateway that will be important to our simulation. In this example, we have a rocket coming from Earth bringing resources that will dock with the gateway in a bit. We are using the gateway for reducing costs and improving efficiency of transporting cargo between the planet and the moon. And also a capsule coming from the surface will dock with the gateway to get the resources and bring them down to the lunar tech base. The next step of the simulation will be a combined operation between our Federates, the Lunar Hopper, and the Explorer rover. The logistics center is sending some of our hoppers to investigate a few sites that are difficult to reach for resources. We will focus on one of them. This one, while descending, has scanned the surface and has detected a valuable resource. After that is done, it will then send a request for one of the explorers to come and investigate, also to drill into the surface and collect samples for sending to the laboratories for further research. The other hopper has also reached its destination. However, the resources are either not valuable or too difficult to reach by traveling along the surface. As a short conclusion, we believe that our multi-purpose vehicles and our scientific laboratories will be extremely useful to many missions and could contribute a great deal on various projects other than the core functions of the Lunar Tech project. Thank you.
Thank you. This is great. Fantastic job. Thanks, guys. Let's go to UCF base operation.
Hey, Oh, Alex got up. Never mind.
And yeah, this is gonna keep going down. Okay. Do you want to explain it, Ryan, or should I?
You can go ahead.
Okay.
Don't mind.
So our federates are static because we are the landing pad and the landing pad walls. And living quarters, we do have an interaction in the federation working to connect power with a interaction that we designed that's supposed to work with the other UCF teams federates, but we weren't fully able to implement that. But we were able to get our federates to be able to position on the moon and then move and actually be able to get them set up.
We have the most important part in our positioning was the landing pad walls and adjacent to our landing pad, and it's used to protect the debris or any sort of offsite object that attempts to interact with the landing pad. So I think that does its job right there. And yep. Alex, do you have anything else to say?
No.
Great job, guys. Thanks.
Thank you.
Next, we have UCF Moon Mars team.
Yes, just give me 1 second here. Okay, can you see my screen?
Yes.
Okay. I'll try not to take too much time here. So I'll show you the solar panel feder we have running here. So it's been running already. So it's already at its max charge amount, which I have it set to 100,000 right now. And then here in Dawn, we have our reflector rover and our solar panel. You see this is in the sun. You have it, and then this is not in the sun, so you can see it being affected by sunlight. And then I think Will has the reflector rover running.
Yeah, I have a bit of a similar issue as somebody else has had, where the console log is getting drowned out by all the other stuff that's running. So I can't really show the position or the power or the sunlight condition that it outputs. But those are the three things that our Federate is publishing. But that's what we have.
That your federate is producing data and interact and publishing and subscribing information, right?
Yes.
Okay, let's go back to Brunel University.
I'm here. There is a lesson here for our team, is that I believe to connect to the central federation, there must be a plugin installed in that end and connected to the federation, because my real engine cannot find the plugin. However, I switch everything back to my local, and I can actually show you a demonstration on my local, and we will work on the remote in future.
Okay. Yeah. Yeah.
Is that okay? Or
yes, that's fine.
Sure. Thank you.
You want me to come back to you? We can go
we-
to Alice's team first, and then we can come
Sure.
back to you.
Okay, great. Thank you.
Yeah, sure. Let's go to
Hello.
MT Mine's Alice
Hello.
team.
Hello, Zukon. Yes, we are ready.
Oh,
I will not lose time and share my screen.
please go ahead and share your screen.
Okay, I don't know if you can see. Is the screen visible for you?
Right now I'm getting a blank screen. I think it's loading. It's on YouTube it shows the eclipse.
Yes, exactly. The eclipse.
Yeah. It's probably just on my end. So.
Okay. Okay. So basically, in on this side, on the right side, we have the lunar rover, and the idea we want to send the all the informations that lunar rover have. Lunar rover might transport the lunar soil, might transport water. So all these things we transport them into the oxygen production system that we have in this side. So if I demonstrate, for instance, on the lunar rover, from the lunar rover, I want to transfer. I can transfer soil, minerals, water, hydrogen, and oxygen. I'll go right ahead and transfer soil. It requests me how much soil I want to transfer, and I will click A. If before executing this part, I want you to see that on this side, the lunar soil mass is equal to 0 kilogram. And the moment I execute, it takes some time to initialize the transfer, but we'll see the value changing exactly like requested in here. Okay. We can see that lunar soil mass now it's 9.9, 9.8, sometimes 100. So we can see that lunar soil is a good. I will go demonstrate with water too. So I can transfer. I can. I want to transfer water to deposit, and I want to deposit. If you see the value in here is for the water is 99.9. If I let's say if I transfer 1 cube meter, we can see now that the water volume is 50.9 cube meter. So this is how we decided to have the lunar rover interact with our oxygen production system federate. And besides that, I would like to give the stage to my teammate Kanta to actually demonstrate the 3D model that we have with Unity. Thank you.
Okay, so I will share the Unity project we made. Unfortunately, we weren't able to develop the plugin to connect Unity to the HLA. So I will only show what should have been connected to HLA. And so we are here. If you can see my screen. We modeled the whole oxygen production system. If it wants to run. Okay. And so we can move around and see that for each part of the system, we have gauges that allows us to show the different levels of resources within the system. So the first tank on the right here is the oxygen tank. Back there we got the hydrogen tank. Here is the water tank.
that can provide water to rovers that needs it, or be used as a storage for rovers that gives us water to produce oxygen. Then we get here the storage for minerals byproduct produced from the transformation of lunar regolith to water and mineral soil. And on the reactor, we got the gauge for the lunar soil mass. And so as we weren't able to connect it to HLA, the only way to make the gauges move, I'm using the keyboard. So I can show you that when the level of resources decrease or increases, the gauges evolve at the same time to show at which point the resources are present within the system for the different component and resources of the system. And yeah, that's it for the Unity part.
Very cool. Thanks. Okay, let's go back to Brunel University.
Hi again, Zukwan. I'm going to share the screen.
Okay, please go ahead.
Elon.
I hope you see the screen. I first pitch RTI. I reconnect everything to the local federate, and we can take you to.
I see your screen.
You see a screen, great. These are our time advancing, which looks good, and we have everything connected. And I'm just gonna connect the. Oh, yeah, I'm coming. And I'm gonna run. This thing almost never works in real time. Hopefully this time it does. So plugin found. And every time that this character clicks on the button, we must have an interaction. Except there are a few interactions that is going on already with the vehicle that I show you how it's built into the plugin. And if I press R, and also so I'm going to just come out of this because we already have seen this in the video, and this is kind of a little bit of maybe a cheat because that's what we want to implement on further in future. All the implementation, the interaction is built into the blueprints of the rover that we called it, but it's the rover and the control panel, and these are where the interactions are happening. And every time we interact with something, we had to register it and pass it on. However, I want sorry. Anyone ask question?
All your interactions programmed using the blueprint, and then
right.
That your federate is programmed in blueprint and it connect to the federation.
Exactly. Yes. However, I have tried to put my interaction into the HLA. However, it suddenly got too complex, and maybe this is something that we do next year. With the Dawn, because now everybody has to have one copy of Unreal Engine in their system for this to work. So this was not very practical.
Very good. Is there anything else you want to demonstrate?
No, thank you. Thanks for your attention. I
Thank
stop
you.
sharing. So cool. Thank you.
Great job. Thanks. Great. I want to thanks all the students again for the excellent work they have put together this year. So let's give them another round of applause, and we conclude our. Yeah.
I'm sorry, Zukwan. We are speaking from the Naval Academy. If we have a little spare time, maybe if you saw there was a placeholder for an animation for a video in our slides. It wasn't ready at the time of presentation. We have it now. May we share it with you now?
Yes, please. Go ahead and share. We got maybe 2 minutes.
Thank you. For the second video. Due to the low light conditions on the dawn, we want to present our textures and stuff.
So this year our scenario is in the South Pole, and so as we all know, the lighting conditions very challenging. The South Pole, probably seeing the low light conditions.
These are the same federates using the exact same models in Dawn, except this is done in Blender using the Cycles renderer. And also we're using the CGI Moon kit from NASA.
So it's driven by the data produced from your simulation. Is that correct?
No, it is using the same models and is only for visualization purposes. And that was all of it. Thank you very much.
Great job. Thank you. Thanks. Right. I'll give the floor back to you, Mike.
Thank you very much. Absolutely outstanding work, everyone, everywhere. This was, I think, Duquan can correct me if I'm wrong, but the most we have seen, the most interactions we have seen, the most complexity we have seen, the greatest advance from event to event for any of the teams across the board. Just absolutely good job everywhere around. Everybody just absolutely phenomenal. Any final questions, concerns, thoughts, or things that people want to go add?
May I quickly ask if for those teams that successfully implemented Dawn share documentation for future, that would be great, or collaborate on getting. So the Dawn was our challenge this year, so that would be great if we can collaborate with other teams through yourself more during the year, and hopefully more for the next event. But I'm grateful for all the help you have done, and the company's pitch, especially the technologies. Thank you, everyone.
Okay, I think that's an absolutely fantastic idea. If I know if the groups would have it, would put each of the groups would put together a page or two of the things and what they did to be able to integrate, be able to go work the things they were doing with Don, and send them to both Zuquan and I, or post them in the on the Discord. Post those documents. We would let us collect the different approaches, different things that work, and we can pull from those, or just pull them together and go publish them the way that they sit right there. That'll also be a tremendous input to I have a team that is working on an open source releasable version of Don, and that would help them be able to understand how everybody attached and make sure that at least those methods of attaching and sharing data and moving data around work as well. So if I could ask as a favor for those teams to go pull that together, put together a narrative so that we can go share it, and so that we can also go feed it in for the other teams, or for the teams that are looking to go probably modernize Don by about 15 to 20 years into a little more modern product, and also to line up a little better with what the NASA teams are doing with Unreal, which gives us some phenomenal capabilities over what Unity is able to go do. I think that'd be grand. And thank you very much for that, Mazir. Anyone else? Suggestions, thoughts? I forgot. I want to thank everyone who helped us put on SEE 2023. I want to thank the sponsors and folks we had at the beginning, the people that helped go lead this. Zuquan for being there every week to go tie in, or being there almost every week to go tie in. Paige and Chetan for being there the rest of the weeks to go tie in and go keep things running for us, and be able to go pull this together from a technical point of view. These people are phenomenally talented in their field, way more so than I am, way more so than I will ever be. And they're the reasons for the advances that we're seeing and the stuff that we're seeing going forward and everything else. So if we'd all give them a round of applause and thank them very, very much for what they've done. Final words from Zuquan? Do you have any final comments, Zuquan?
I just want to emphasize that all the teams have done a great job this year, and especially the first comers. And I want to thank all the students for their dedication and the works to pull these together. I know it's difficult to put together a integrated sim, and it's even more difficult to coordinate across different time zones and different backgrounds. So I think you guys have done a fantastic job this year, and I look forward to work with you again next year. So great job, guys.
That's good. I can see posted in the chat is the link to the YouTube for this, so you guys can go look back on it, be able to go share it. I want to thank Damon for helping us set the new website up. I'm assuming that link will be there very, very shortly. And without anything else seeing there, I want to declare, actually, it's very obvious that SE 2023 was a phenomenal success. And I want to say things are closed, and we look very, very forward to sharing with you in the off season. And then probably in about another 7 or 8 months, we'll be starting up, maybe a little bit earlier. I might try to do a January start, or not a January, December start, or a November start to give teams a chance to get a little bit further along and get a little more time to go work on this. We'll be working on those types of things in the off seasons and talking to the different sponsors and the mentors and the faculty that we've got to see if we can make that happen across the number of different school calendars, time zones, and calendars that we've got here. Again, thank you very, very much. SEE 2023 is done, and congratulations, you all were absolutely, absolutely phenomenal.
Outstanding all.
Great job, guys.
Really nice.